Okay, hi everybody. Today we're going to be doing a lesson on permutations. This is an added lesson in addition to our textbook. And our objective is to find permutations, so I have to tell you what this is, and to use permutations to find probabilities. So we're going to go over all of this. Permutation, this new word for you, is an arrangement or listing of objects in which order is important. Okay, when we're doing something that has to be in a set order, then we're talking about a permutation. So copy that down, we'll do some examples. Okay, we have 4 examples today, and then that's it. First example, Julia is scheduling her first 3 classes. Her choices are math, science, and language arts. Use the fundamental counting principle, and this is what we learned in our last lesson where you multiply the events, to find the number of different ways Julia can schedule her classes. Now, first of all, for those of you who always forget, you should be copying down all of the problems. Second, order matters here because if she picks something for first period, she's not going to have it again for second period or for third. There is a certain order here. Now, the way you're going to do it, the way that I recommend doing it, is we have 3 different spots: first period, second period, third period. For first period, we have 3 choices. We have math, we have science, and we have language arts. So 3 would go here. For our second period, 1 of these will have been chosen. So 1 will be used up, and now we'll only have 2 choices left to go into second period time slot, which means you'll only have 1 choice left there. So you do 3 times 2 times 1. 3 times 2 is 6, times 1 is 6. So you will have 6 choices. And this will be 6 different ways that she can set up her schedule, depending on which one goes first, second, or third. So this is a permutation because the order matters. Let's try another one. In how many ways can the starting 6 players of the volleyball team stand in a row for a picture? Again, the order matters because depending on which way you put the row, someone will be first in the row, someone will be last or in the middle. So the order matters again. So we have 6 players, so 6 spots in the row. 1, 2, 3, 4, 5, 6. For the first spot in the row, you have 6 players to choose from, so 6. Then you will have 1 will be picked and put there in the first spot. Then you will have 5 people to choose from. Then 4, 3, 2, and 1. Okay, so you multiply all of these. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. I'm just going to grab a calculator to make sure I'm doing this right. So 30 times 12, got that, times 2. 720 options, 720 ways that we can arrange that row. Arrangements we can write. Now, just as a side note, some of you may have seen this already. When you're multiplying like this and it's going down, that's called a factorial. Okay? And a factorial is when you're multiplying down like this where each number is decreasing. And we write this, if we wanted 6 times 5 times 4 times 3 times 2 times 1, we could write it like this with an exclamation point. And what this is read as 6 factorial, 6 exclamation point, means 6 times 5 times 4 times 3 times 2 times 1. So, for example, if I wrote 4 factorial, that means 4 times 3 times 2 times 1. It's just a faster way, it's a shorthand way of writing all of that out. Okay, because if I had to ask you to do 10 factorial, that would be a lot to write out. Okay, a couple more problems and then we are done. Permutations and probabilities. So now I'm going to be asking you to do some probability questions. You have 2 more problems that you should be writing them both down. A swimming event features 8 swimmers. This is a shout out to my 8th period class in this year. Sam, Evan, William, Kevin, Noah, Justin, Youngsu, and Eric. If each swimmer has an equally likely chance of finishing in the top two, so first and second, what is the probability that Kevin will be first and Justin will become in second? So let's first figure out the total amount of choices we have, and then we'll figure out the probability of Kevin coming in first and Justin coming in second. The total amount of choices, you have 8 people, you have first place, 8 people can come in first place, then you could have second place will be 7 times 6, 5, 4, 3, 2, and 1. These are all if we went all the way out to the end. We're only talking about first and second. So that would be first place, second place. We don't need all the rest of these. This was if you were doing the entire race, all the combinations. We just want first and second place. We want to know how many different probabilities for those. So 8 times 7, there's 56 combinations that we could possibly have for all of the first and second places. 56, and we want 1 out of all of these. One where it's Kevin and then Justin specifically. So that's 1 combination out of the 56, and that would be our probability. Okay, try one more, and then we are done. 2 different letters are randomly selected from the letters in the word math. So we have M-A-T-H. We want to select out 2. What is the probability that the first letter selected is the letter M? So when we go to select the first letter M, we have 4 choices. And then the next letter selected is H. So after we've pulled out M, hopefully, we would have 3 more choices. 4 times 3 is 12. What is the probability that we get that? That would be 1 out of 12. All right, that's it for tonight. Have a good one.